Hey guys, welcome to the channel. We've all seen levers in one form or the other. Assume that we have a ball of 100 kg placed on one side of a lever. To lift this ball, a huge force has to be applied at the other end. But when the point at which the force acts is at a greater distance, the force required minimizes. This is how the lever works. But levers are limited by the length of the arm. By using pressurized fluids, the force that you require can be transferred to other components much more easily without this limitation. But why are fluids used? Well, you might remember Pascal's law from textbooks. Blaise Pascal proved that in a closed container, water transmits pressure equally throughout. Fluids have the ability to transfer pressure much more effectively over a long distance, and by using hydraulic components like valves and actuators, the transfer can be precise. For example, consider a U-tube filled with water. If we apply a force on one end, the other end will experience the same amount of force. Now, if one end has increased area and force is applied at the other, then more force will be experienced at the wider end because of the increased area. This advantage makes it possible to apply large forces by means of a hydraulic press. In simple words, fluid power is the use of pressurized fluids to transmit power. There are many places where we come across precise movements controlled by pressurized fluids. Ever wondered how a fast-moving car stops in such a little time? Or why the steering control is so smooth? Well, that's possible because of the hydraulic brakes and hydraulic steering used in automobiles. Heavy equipment can also be controlled precisely using pressurized liquids like hydraulic oil. Fluid power can be classified into two types based on the type of fluid used. Hydraulics use liquids such as water or oil, while pneumatics use compressed air, which can be easily extracted and released back into the atmosphere. Fluid power systems are designed to perform a work. This work may be either in the form of linear motion, as in a fluid cylinder, or a rotary motion as in a fluid motor. Due to high working capacity and speed, fluid power systems are used extensively in almost every branch of industries. A mechanical system requires complex gear systems and levers to multiply forces. But in a fluid power system, such as a hydraulic press, forces can be multiplied easily up to a greater limit using fluids. Apart from that, a fluid power system can provide constant force or torque. For example, a lawnmower has two different speeds, one being the engine speed and the other being the mowing speed. These speeds can be varied independently by using a hydraulic transmission. Finally, fluid power systems use fewer moving parts as compared to mechanical and electrical systems. Thus, they are simple and economical in maintenance and operation. Hydraulic power steering is helpful in converting a small input torque into the wheel movement with the help of a hydraulic circuit. So, to sum it up, fluid power is used in numerous applications all around us, from hydraulic lifts to excavators. Well, that's all for this time. We'll be back with fluid power systems next time. Bye.